short data one here. This is number 198, part 198, line 18i. Reynolds Chilton Colburn J-factor analogy velocity stress rates 5G Wow Seti. There's the alien radio signal, and this is the Reynolds analogy. Again, this is what the 5th video it's come up in. I didn't notice that when I was doing stuff. Anyways, I hope I'm not repeating myself because it looks like I am. Sorry, I was tired when I did these, so I don't know what's going on here. So Reynolds analogy is popularly known to relate turbulent momentum and heat transfer. The main assumption is that heat flux QA in a turbulent system is analogous to momentum flux T, which suggests that the ratio TQA must be constant for all radial positions. The complete Reynolds analogy is, and there's the formulas there. Experimental data for gas streams agree approximately with above equation if the Schmidt and Prandtl numbers are near 1.0 and only skin friction is present and flow past a flat plate or inside a pipe. When liquids are present and aeriform drag is present, the analogy is conventionally known to be invalid. I believe there is a formula with this one, just so you know. In 2008, the qualitative form of validity of Reynolds analogy was revisited for laminar flow of incompressible fluid with variable dynamic viscosity. It was shown that the inverse dependence of Reynolds number Re and skin friction coefficient Cf is the basis for validity of the Reynolds analogy. In laminar convective flows with constant and variable U for U equals const, it reduces to the popular form of Stanton number St, increasing Re, whereas for variable U it reduces to St, increasing with decreasing. I don't know what this means. Hopefully you guys know what that means. Consequently, the Chilton-Colburn analogy of STPR2 divided by 3, increasing with increasing CF, is quantitatively valid whenever the Reynolds analogy is valid. Further, the validity of the Reynolds analogy is linked to the applicability of Prigogne's theorem of minimum entropy production. Thus, Reynolds analogy is valid for flows that are close to developed, for whom changes in the gradients of the field variables, velocity and temperature along the flow are small. Chilton-Colburn J-factor analogy is a successful and widely used analogy from heat, momentum, and mass transfer analogies. As you notice, there's a lot of things coming up about heat, momentum, and transfer, velocity, transfer rates of particles. So what comes up with this one is fermions plus neutrinos plus compressed gas equals velocity. Now that was in the alien message in line 17, and it comes up again on line 18Z. And we'll be going into a little more detail of what type of formula we're going to need to get the fermions plus the neutrinos plus the compressed gas to equal the velocity of 5G.